Okay, this is an introduction to Chapter 2. Chapter 2 is really a chapter of review for us. It's looking at different properties, especially around addition and subtraction. We're going to really spend most of our time in class on Chapter 3, which is solving equations, but we use the same ideas that we're going through in this chapter here. So the video is really put together for any of you who feel like you need a little bit of review around number lines, addition, subtraction, positive and negative numbers, and how to combine them. Okay? So have your book ready and somewhere to take notes. And let's begin. Okay, so we're looking at section 1 to start, and the title is Basic Assumptions. What they're really getting at with that idea, basic assumptions, is that there are some things that we need to know are true in order for our math, our algebra, to work. And those things that we need to know are true are closure property, commutative properties, associative properties, and the properties of equality. I'm simply reading off of page 45 in your book. What I'd like you to do now is pause the video and take notes on each of the properties listed on page 45 and 46. You'll see them in gray boxes. After you take the notes, I want you to write down very specific questions that you have and bring those to class. We'll go over these properties in more depth there, but only based on the questions that you bring. Okay, now that you've written down your notes on properties, we're going to look here at these two problems. A couple of the key words that come up in this section are terms and factors. What we're looking at for part A is combining like terms. So in other words, we've got 7, which is just a number, 5, which is just a number, and then 9m has the m inside of it, right? So we know that m is a number. We don't know what the number is, and so we can't combine this with addition or subtraction to anything that doesn't also have this number m in it. However, we can take the terms, we call them constant terms, the ones that have just a number in them. We can take the constant terms and combine these. So what I'm going to do really quickly is I'm going to use the commutative property to switch the order of the terms, each of these terms, in this expression. All right, just a simple application of the commutative property. I switch the order of the 9m and the 5, that way the like terms are together here. Now that the 5 and 12 are together, I add them, since they're like terms, I get 12, and the 9m stays by itself. I applied the commutative property again, switch the 9m and the 12, so I have 9m plus 12 to get my final answer. Now it isn't wrong to keep my answer in this form, 12 plus 9m, but convention, or what normally happens, says that we're going to have the variable first and then the constant term. Now in the second problem, 2x times 3y times 4z, I'm just going to first highlight each of the coefficients, 2, 3, and 4. Coefficient being the number that it's multiplied by a variable. Now what I'm going to do is recognize that in this line, I really have 2 times x times 3 times y times 4 times z, right? So I just have this line of multiplication. Now I'm going to apply the commutative property again, and notice that I can rearrange multiplication into whatever order I'd like. So here you'll notice that I've rearranged it so each coefficient is together, 2 times 3 times 4, and each variable is together, x times y times z. Now, rather than putting a multiplication right inside here, I'm just grouping the coefficients together and the variables together. So now I can simplify what's inside this parentheses, which is 24, and then x times y times z just stays as x, y, and z. And the final step is just to remove this dot multiplication. So I've got 24xyz. So in this section, we're essentially spending some more time with order of operations, and now we're throwing in combining like terms, which is something that we've been reviewing sort of softly in class so far, and now we're officially reviewing it together. We're also reminding ourselves of the properties that we have studied before in previous math classes, and we're giving names to each of the steps that we're using while we're doing order of operations. Okay, now, in both sections 2 and 3, what we're going over is just some ideas around addition. Addition is something that we've been working on for many, many years, probably since we were very young. But here we're just talking about why addition works. And it's supposed to help clarify some of the confusing situations around, like, am I supposed to add or subtract? Which way does adding go? Is my answer going to be positive or negative? And so we're going to spend some time here just gaining some of that number sense so that we can check our answers. So to start and give us a reference point for all of these properties, I just want to walk through example 1 on page 54. You'll notice that I'm skipping from section 1 to 3, and then we'll fill in with section 2. Now, here's a simple order of operations where we're just looking at addition of positive and negative integers, or numbers, right? And so I want to show you 2 different ways that we might simplify this expression. One way, we're going to be simply working from left to right, which is what I've been reminding you to do throughout the whole first month of school. The second way is going to be applying the commutative property, which we looked at just a second ago. All right, so you notice in this first way, I'm just working from left to right in here. So I like to color code. So the first 2 terms that I put together are 7 and a negative 9, which gives me a negative 2. Then I'm going to do negative 2 plus 15, which gives me 13. And as I am combining terms, I'm just bringing what I don't touch down. And then combined terms bring what I don't touch down, right? And so now I have 13 plus a negative 2 gives me a positive 1. The second way we might interpret this problem is that we've got both positive numbers and negative numbers in this problem. We also have addition in between each. So I might apply the commutative property to rearrange so that my positive numbers are together and negative numbers are together. Now I can simply combine my positive numbers and my negative numbers. Now when I combine this 22 plus a negative 21, you'll notice that I also get a positive 1. Okay, so what's the point of all this? Well, it's simply to show you that we can look at one problem in 2 different ways. There are many different ways that we can decide to combine these 4 integers using our properties of addition. The reason that we're spending some time thinking about this is eventually, when we're using only variables, only abstract representations of numbers, we really are going to have to rely on our knowledge of these properties in order to trust the work that we're doing. So we're going to spend some time now looking at this closely so that when we're using variables later, everything will make more sense. Okay, one of the things that we love to do, or I love to do in class, is to think about numbers in terms of the number line. Thinking about addition is moving in the positive direction, subtraction moving in the negative direction to the left. Positive numbers are to the right of 0, negative numbers to the left of 0. And so what I'm going to do is jump back to chapter 2, section 2, and look at this same simplification problem here in terms of the number line. All right, so what I'm going to do is color code. So anytime that I'm moving to the right or in the positive direction, I'm going to use red. I'm looking at this first number, 7. I'm going to start at 0 and move 7 units to the right in the positive direction. All right, 0 to 7. Not bad. Now, my next number is a negative 9. So what I'm going to do then is start at 7, where I left off, right? I went 0 to 7. And now I'm going to start at that 7. I'm going to move back 9 units, right? So once I move back 9 units, I'm actually at this -2. That's kind of cool. If I were to add 7, positive 7, and a -9, it's going to give me a -2. I've got a net distance, meaning a total change in distance of -2 units, 2 units to the left. That's pretty cool. All right, so now I've represented the 7 and the -9. Now I've got to represent this 15. So I'm going to start at the -2 here and count 15 units to the right. I've got a positive 15, so 15 units to the right. When I go to the 15 units to the right, I'm going to end at positive 13. Right here, positive 13. So now I've combined all of these 3 numbers, 7, -9, and 15, and that's given me this net change, 0 to 13. All right, one more number. I've got a -12, so I'm going to start at this positive 13 here, where I ended, and I'm going to move back 12 units. That's going to take me to 1, a positive 1. So at the end of all of this, I'm going to have changed. I started at 0 right here with that 7, and I ended here at 1. So I've moved a net of 1 unit, which is exactly what I got with way 1 and way 2. So all of section 2 of this chapter is about using the number line to conceptualize what's going on with these kinds of simplification problems. I encourage you to spend some time thinking about this. It's really going to be helpful, especially when we move into absolute value and inequalities.